Okay, we're looking at question 6. Determine the domain and range of each relation. Use a graph to help you. Let's edit that with this. Okay, so determine the domain and range of each relation. Use a graph to help you if necessary. And I basically wrote these. I actually put them in Desmos for now to see the domain and range of each of these functions. And I took a picture of them. So here's the first one. This is y equals y equals minus x plus 3. Now, as you can see, the y-intercept is plus 3, and we have a slope of minus 1 over 1. So the rise is -1 and the run is 1, -1 and 1, etc. And that's how it's drawn. And if, as you can see, the domain is actually equal to x's element of r, and the range is x's element, y is an element of real numbers. Okay, and it makes sense too, because look, for every number we have, for every real number, you just multiply it by -1 and add 3, and it's going to be different every time. If we do the vertical line test, we see there's one value for each value here, and there's no restrictions on what x can be, and then y is just that same number. Uh-oh. Not sure if it's upside down or right side up. Regardless. Let's move on. I'm done. Move to my next question. I have y equals x plus 1 squared minus 4. And when I graph it, if you remember, the y-intercept is -1. And it's the opposite here, the opposite sign of that. And down 4. 1, 2, 3, 4. And that's my vertex right there. So the x values actually, they go on forever, right? So x can be any number. Doesn't matter what it is. You're just going to square it. It's going to turn positive and subtract 4. So actually the domain is x element of reals. And the range, it goes all the way up, but for some reason, it doesn't go anywhere below -4. So the range is equal to, you put the curly brackets, y element of r such that y is greater or equal to -4. And that's my domain and range. Is it a function? This is not the question, but yes, actually it is, because there's only one value for any x value. Okay, moving on. Done. Whoops, what am I doing? There we go. Yep. We have our domain, which is, it goes in every direction. It goes in the x direction. So x is an element of real number, and put that in brackets or curly brackets. And that's called domain. What can x be? The range is what can y be? Well, y is also an element of real numbers, right? But here's the thing about it. Look, y can only be positive, right? This is going to be positive. matter what, actually, it's only going to be negative. Okay, the greatest this number can be, it's going to be negative. Look at that. It's multiplied by negative 3. This is negative. This is positive. Negative times negative, y can only be negative plus 1. And if we look at the graph, see this? We can just look at the graph. What can y be? Y can only be less than or equal to 1, such that y is less than or equal to 1. And that's my domain and range. Once again, this is a function. For every x value, there's only one y value. Whoops. Okay. So that's the domain and range. Let's check it. Yes, it's correct. Done. Let's move on to D. Question D. First of all, is this a function? I know that's not the question, but we'll talk about it anyway. It is not. What is the domain? Well, the domain seems to only go 1, 2, 3, to 3, and to negative 3. So we say something like x, we'll say domain, x is an element of real numbers such that x is greater or equal to 3 and less than or equal to 3, negative 3. Let's write that a little nicer. So it goes from negative 3, x, to 3. Now x is greater than or equal to, and x is less than or equal to 3. And actually, the range is pretty much exactly the same. We have y, element of real numbers, such that y is between 3 and negative 3. What is y? It's greater than negative 3 and less than or equal to 3. Okay? And that's the y direction right there. It goes from 3 to 3. Negative 3 to 3. And there's no value for y beyond that. Okay, we're done with that. Let's talk about this. Okay, so let's throw this in. And if we draw, actually should never approach. I have a value that should be an asymptote right there. And an asymptote right there at y can never equal 0. Let's take a look at that algebraically. And x can never equal negative 3. X equals negative 3. It can never equal negative 3. Let's look at this algebraically and see why. If I look at this, if x equal negative 3, then y equals 1 over negative 3 plus 3. What's that equal to? Y is equal to 1 over, that becomes 0. Can this be the case? No, so x can never equal negative 3. But it can equal any other number. Think about it. Can it equal any other number other than negative 3? Yes, it can. There's no restriction on it. So what do we say? Do we say the domain is x element of real numbers such that x unequal to negative 3? And the range, let's fix that up a little bit. There we go. That's better. And we have the range is the same. X cannot equal 0. Sorry, y cannot equal 0. Let's see y. Y equals 1 over x plus 3. Is there any value that this can make this 1 into a 0? No. If it was infinity, basically, if you try it in a calculator, just divide 1 by larger and larger numbers. It will never hit 0, but it will come close to 0. Range. So we can talk about that more in person. Y is the element of R such that y is unequal to 0. And that's that. Finally, we come to our last equation. And we say y, whoops, what happened here? Y equals, basically, look at this. If I look at this, what can't this be? Well, 2x plus 1 has to be greater or equal to 0. It has to be. Why? Because if it's not, it can't be a real number. It cannot be, it can't work. Because the square root of a negative, you can't get a square root of a negative. Okay? So how do I check this out? I just do it like this. X squared, 2x. I pretend like this is an equal sign. It's the same thing. Almost. Greater or equal to 1. Negative 1. Moving this to this side. Okay, then what happens next? X is greater or equal to negative half. And if we look here, that's 1, 2, 3, 4, 5. This one is negative half, and x is greater than negative half. So we can see just from the graph that the domain is defined. X is an element of R such that x is greater or equal to negative half. And the range, okay, let's look at the restrictions on y. We'll look at the graph. We already know from the graph that y is only defined for greater than 0, greater or equal to 0. But let's look at this equation here. Can this ever be negative? Can I take a square root of something and it be negative? No. In fact, the square root of 0 is, it's same thing as 0 times 0, which is equal to 0. And the square root of 1, oh, never mind. The graph is not just a straight square root, right? So this can never equal, y can never equal negative. So what does that mean? Well, we say y is an element of reals such that y is greater or equal to 0. And that's it for question